Alright, so for question 12, which has got a lot of words, but let's see how we go. So the first thing we want to do is, let's look at A, expand. Oh, we can do that. Alright, so let's expand f of x. My pen's too thick. Alright, let's try now. F of x is x minus h squared plus k. So if we expand that, we square the first times double the product. We've got h squared, we've got k. Alright, so you can see if we were thinking of this as a, which it is, a quadratic, you can see my first term, or my a value, is 1. My b value is in front of the x, so minus 2h. And my c value is everything else, so h squared plus k. So if I want to look at the discriminant, which is b squared, so minus 2h squared, minus 4ac, a is 1, c is h squared plus k. So you can see when I square a negative, I get a positive. I square a 2, I get a 4. I square an h, I get an h squared. Expand out these brackets, and you have minus 4h squared minus 4k. So you can see that the 4h squared minus 4h squared cancels, so you're going to get minus 4k for the discriminant. So we're good for that one. Alright, then use the quadratic formula to show that the axis is x equals h, and find the zeros. Alright, so using the quadratic formula, again, we've got this. And we've also now got our discriminant, so we don't have to actually work that part out. So negative b, so in this case 2h, plus minus, the square root of the discriminant, so the square root of minus 4k, because that's the discriminant, all on 2a, and we know a is 1, so all on 2. So you can see I'm going to have 2h on 2 plus minus, I'm making it 2 fractions, so we can see the axis of symmetry easily. Now, we can square root 4, but we can't square root the minus. We do know the square root of 4 is 2, so I'm going to pull that out. But we still have a minus k in there. Okay. If I just simplify that, we get an h plus or minus square root of minus k. So remember, we know that this part where is the axis of symmetry, and then we're adding a bit and subtracting the same bit. So we can see the axis of symmetry, or you can use negative b on 2a as well, but the axis of symmetry is x equals h, as expected. There we go, as expected. And the zeros h plus minus the square root of minus k. So here, these are the roots, they're the zeros, this whole bit. So just the h gives you the axis of symmetry, but the whole bit, they're the zeros. Alright, so let me rub that out and we'll do b. Hopefully that helped a bit. Alright, so for b, this time we are expanding out. Just going to go up a little bit. Oh, alright, I didn't like that. That's okay. Alright, so this time we're expanding out f of x being x minus alpha, x minus beta. Expanding it out, we get x squared, we get minus alpha x, minus beta x, and minus times minus, so positive alpha beta. So if I just simplify that, I get minus, this is alpha and beta are both negative, so I'll just put them together, plus alpha beta. So just factorize by negative and the x for the middle two terms. Alright, so you can see from that, if I do it again, a equals 1, because that's a quadratic here, b is negative alpha plus beta, that's b. C is alpha beta. So if it says, alright, so we're going to find the discriminant, we can do that again. So b squared, so remember I'm squaring that negative as well as the alpha plus beta. So square of a negative, that's easy, right? So negative times negative positive, so I'm just going to worry about the bracket part. So b squared minus 4a is 1, c is alpha beta. Okay, so we just get that. Now, if we expand that, why did we want to expand it? Did I expand that and show that? Alright, so yeah, so we're trying to show the discriminant is alpha minus beta is all squared, which is not at the moment, so we need to expand and simplify. So square the first term, double the product, square the last term, and we've got minus 4ab. Simplify that, we get a squared, alpha squared, sorry, 2 alpha beta minus 4 alpha beta, so altogether minus 2 alpha beta plus b squared. Now that's just the perfect square, but it's the negative this time. Alright, so yes, the discriminant is alpha minus beta all squared. So again, if we're using the quadratic formula, we do x equals negative b, so here's our stuff, and we've got our, oops, I don't know why I write a, we've got our discriminant there. Oops. Alright, so negative b is alpha plus beta, right? Negative b plus minus square root of, alright, so b squared, oh sorry, discriminant we've already got, it's down here. So we know it's alpha minus beta squared, all on 2a, a is 1, so that's just all on 2. Now if I separate again, because we can then see the axis of symmetry, will be that term, so that part's the axis of symmetry, remember, and then we're adding, subtracting around it. Now the square root of the square is just itself, so that's what we get there. Now, so if you wanted the axis of symmetry, again, you're just taking kind of that part, x equals alpha plus beta on 2. So remember, for a quadratic, that's where the x value of the vertex occurs. So we know that that's alpha plus beta on 2 is the x value of the vertex. And remember, we'd sub it into the y value in order to find the y value. So, but before I do that, let's just go back to here and simplify. Alright, so let's just use the plus sign first. So I'm going to have alpha plus beta on 2 plus alpha minus beta on 2. So remember, it's all on 2. So what I'm going to have is, if I use the plus, it's going to be alpha plus beta plus alpha minus beta on 2. Yeah. If I use the negative, it's going to be alpha plus beta. I'm going to do minus alpha and then minus minus beta, so plus beta on 2. So what do I get there? So 2 alphas on 2, and here I get 2 betas because the other bit cancels out, the alphas cancel out on 2. So the roots are going to be both alpha and beta there, as expected from this form. So we know the roots are alpha and beta, so we expected that. So that's all good. Now, if we want to find the y, let's go back to the y value here. Alright, so the y value, so we've got the x value, there it is over here. We've got the x value of the vertex, so we can sub that in to get the y value at that x value point. So we've got x plus b on 2 for the x. It says minus alpha. Now, I like common denominators, so I'm going to put 2 alpha on 2. That's the same thing as alpha, right? Same here, I've got alpha plus beta on 2 minus beta. That's the same as 2 beta on 2 if I make a common denominator, right? Same. Alright, so what do I actually have? Alpha plus beta minus 2 alpha on 2, and we're multiplying by alpha plus beta minus 2 beta on 2. Alright, so we've got this beta take away alpha on 2 in the first one. The second bracket, we've got beta, negative beta, I'll put alpha minus beta on 2. Now, so similar, but a little bit different. So what I'm going to do with the first bracket is factorize by a negative. That means I can put alpha minus beta, right? Because it's still negative alpha, positive beta, which is what I've got here, negative alpha, positive beta. But it just makes it look, no, the same as, okay, that's supposed to be beta minus alpha. There we go. So now it looks the same as the other bracket. So I've factorized by a negative. So it's just negative of that, or that squared. So alpha minus beta on 2 is the same, so squared. So that's the y value. So if I go back over here, I don't know if I'll be able to fit it in. Actually, let's try. So I'm going to have negative alpha minus beta on 2 all squared for my y value for my vertex. RR, which is great because it's right here. Excellent, we've shown it. Hope that helps.